Okay, so now let's try to do a question based upon the color of the coordination compound. So this question asks you, among the following the colored compound is, and it gives you a bunch of options. So first of all, whenever you're trying to determine whether a complex is going to be colored or not, first of all you have to determine its electronic configuration. And for that you have to determine the oxidation state of the central metal atom. In this, Cu is going to be positive, right, because chlorine is negative. So Cu has to be positive. So it's going to be Cu positive, and we know Cu positive's electronic configuration is argon 3d10 4s0. So it's 3d10. 3d10 means that the Eg as well as the T2G is fully filled with electrons. So if the Eg as well as the T2G are fully filled with electrons, then if excitation occurs from the T2G to the Eg, where will the electron of the T2G go? It does not have any place to go because Eg is also fully filled. So excitation cannot happen in this complex, and hence this complex will not be colored. So if your d orbital is fully filled, then that coordination complex is not going to show any color. Second, in the second one also we have to find the oxidation state of copper. So that's 3 because K is a positive ligand. So K 3 plus X plus 4 into minus 1 is equal to 0. So X comes out to be plus 1. So this is again means that copper is in plus 1 oxidation state. That means it is 3d10. That means it is not going to show any color. In this case, copper is in Cu2 positive state because fluorine has a negative charge and there are 2 of fluorines present. So copper has 2 positive charge. That means it is going to be Ar3d9. So that means it has 1 electron less in your Eg. So let's just erase one of the electrons from here. 1 electron less in Eg. So T2G electron can get excited to your Eg, and hence this will show your color. In the last complex again, Bf4 has 1 negative charge. That means this entire complex, that is a coordination pair, is going to have plus 1 charge. And CH3Cn is a neutral ligand. So X plus 4 into 0 will be equal to plus 1. So X is equal to plus 1. Again Cu positive, so that's 3d10. So no color again. So this is how you can predict whether your coordination compound is going to show color or whether it's not going to show any color. The next question is a bit lengthy question. So this question is saying that the octahedral complex of a metal ion M3 positive with 4 monodentate ligands, that is L1, L2, L3 and L4, absorb wavelengths in the region of red, green, yellow and blue respectively. The increasing order of the ligand strength of the 4 ligands is. First of all, Vibgyor: violet, indigo, blue, green, yellow, orange, red. So we know from going from violet to red, the frequency decreases. So if any complex is absorbing violet color, it means it is absorbing a high frequency radiation. That means the energy difference between the Eg and T2G is high. And if the energy difference between Eg and T2G is high, that means the splitting is high. And if the splitting is high, that means the ligand is strong. So higher, if the color absorbed is in the blue-green region, that means the splitting is great. And if the color is absorbed in the red, orange, yellow region, that means the splitting is less and the ligand is a weak field ligand. L1 absorbs red color, L2 absorbs green color, L3 absorbs yellow color and L4 absorbs blue color. So we can say that L4, that is the ligand L4, is absorbing the highest frequency radiation. That means it will have the highest delo. Highest delo means highest difference between Eg and T2G. So that means it is going to be the strongest ligand. That is, the strength of the ligand is going to be strongest. It is going to be a strong field ligand. and if it is red, it means the frequency is less. So if the frequency is less, it means the difference between the EG and T2G is less, because then only a right of low frequency can be used to excite the electron from your T2G to EG. So if a light of low frequency is used, that means EG and T2G's difference is not much. So if EG and T2G's difference is not much, that means del O is less, and if del O is less, that means it's a weak field ligand. So L1 is going to be the least, that is the ligand strength of L1 is going to be the least, and the ligand strength of L4 is going to be the highest. Between L2 and L3, L2 is going to have a higher ligand strength than L3, because L2 absorbs in green, and green has a higher frequency than yellow. So del O of L2 is going to be greater than the del O of L3, which means that the L2 is a stronger ligand than L3. So this is satisfied by the option C. So your option C is correct.